can be intersecting or non-intersecting, that is parallel. Types of angles are acute, right, obtuse, straight, reflex and complete angles, and based on the types of pairs of angles, they are complementary, supplementary, adjacent, linear pair and vertically opposite angles. Now let's see what type of angles can be formed when there is a transversal. Have you heard what a transversal is? A line which intersects two or more lines at distinct points is called a transversal. Consider these examples. Can you locate the transversal? Here they are. Now let's see the angles formed when a transversal intersects two lines. Here line L intersects line M and N at points P and Q respectively. Therefore, line L is a transversal for lines M and N, and this will lead to the formation of four angles at each points P and Q. Let's name them as angle 1, angle 2, angle 3, etc. up to angle 8. Angles 1, 2, 7 and 8 are called exterior angles. Alternate exterior angles are angles 1 and 7 and angles 2 and 8. Angles 3, 4, 5 and 6 are called interior angles. Alternate interior angles are angles 4 and 6 and angles 3 and 5. Alternate interior angles are commonly called as just alternate angles. Interior angles on the same side are angles 4 and 5 and angles 3 and 6. They are also referred to as consecutive interior angles or allied angles or co-interior angles. Corresponding angles are angles 1 and 5, angles 2 and 6, angles 4 and 8 and angles 3 and 7. Now let's see what happens to the corresponding angles if the lines M and N are parallel to each other. Then their corresponding angles are found to be equal to each other. That is, angle 1 equals angle 5, angle 2 equals angle 6, angle 4 equals angle 8 and angle 3 equals angle 7. This can be concluded as an axiom. That is, if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. This axiom is also referred to as the corresponding angles axiom. Now let's state its converse and check out if that statement is also true. The converse statement is, if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel. Now let's try to prove this statement. Draw a line AD and mark points B and C on it. At B and C, construct angles ABQ and angle BCS equal to each other. Produce QB and CS on the other side of AD to form two lines PQ and RS. You may observe that the two lines do not intersect each other. You may also draw common perpendiculars to the two lines PQ and RS at different points and measure their lengths. You will find it same everywhere. So you may conclude that the lines are parallel. So the converse statement is also true. That is, we can write it as an axiom, which is, if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. Let's work out a problem. In the figure, find the values of x and y and then show that AB is parallel to CD. As line T intersects line CD at Q, y equals 135 degrees as they are vertically opposite angles. As line T intersects line AB at P, x plus 45 degrees equals 180 degrees as they are linear pair of angles. So, x equals 180 minus 45, that is equal to 135 degrees. For T intersecting lines AB and CD, the corresponding angles, angle x and angle CQF, are equal. which is 135 degrees. Hence, AB is parallel to CD following the rule of converse of corresponding angle theorem, hence proved. So, we can conclude that when a transversal intersects two parallel lines, we get 4 angles on each point, which consist of pairs of corresponding angles, alternate interior angles, alternate exterior angles and interior angles on the same side. For corresponding angles, we have the axiom: if a transversal intersects two parallel lines, then each pair of corresponding angles is equal and its converse. If a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other.